Hello friends, welcome to a new video. If you are new here, then please subscribe and press the bell icon so that you get notification for new such videos that will help you in the preparation of IIT Jam Physics. So let's start today's video. Today we are going to discuss about Compton Effect. Compton Effect is nothing but scattering of photon by an electron. Okay, pictorially we can represent like this. Consider there is an electron here, and a photon is coming like this. Okay, this is the incident photon, this is incident photon, and this is target electron. While this photon incident on this target electron, this photon get scattered by an angle phi. Okay, at the same time this electron also will move in this direction. This electron will move in this direction by an angle theta. Okay, this is the process happening in Compton effect. So this is scattered photon, this is scattered photon, and this is scattered electron. This is nothing but scattered electron. In this process, you remember momentum and energy should be conserved. That is, total initial momentum will be equal to total final momentum. Similarly, total initial energy will be equal to total energy after scattering. Okay, so this incoming photon have an energy equal to h nu, and momentum is E by c, that is h nu by c. Okay, so this scattered photon have an energy E, which is h nu dash. Here you note that this nu dash, that is frequency of scattered photon, should be less than nu, so that energy of scattered photon will be lesser than incident photon. This is the point here. Clear? Means this incident photon is losing some energy. That energy will go into kinetic energy of this scattered electron. Okay, ready? Okay, then here momentum will be h nu dash by c, and for here for this scattered electron, energy is root of m square c power 4 p square c square. This is from relativity, you know, I think, and momentum become p, which is mv. Okay, initially this electron have energy mc square, that is rest mass energy mc square, and momentum is 0. Clear? So this is the overall picture of Compton effect, and the 3 points also you remember. Compton effect is nothing but scattering of photon by an electron. In Compton effect, momentum and energy both are conserved, and the scattered photon has less energy. That means incoming photon lose some energy. Okay, so let's move. If you write momentum conservation, we get two equations because momentum is a vector quantity, so we need to consider x y direction. Let's say this is x direction and this is y direction. Then in x direction, initially the momentum is h nu by c plus 0, because momentum of electron is 0, which will be equal to then in x direction, this p, I mean momentum of electron has a component like p is here, p, and this is theta, so this is p cos theta and this is p sin theta. Similarly here h nu dash by c is this one, and this is angle phi. So in x direction there is a component h nu dash by c cos phi, and here h nu dash by c sin phi in y direction, sin phi in y direction. So here we will have p cos theta plus h nu dash by c cos phi. Similarly in y direction, in initial case there is no momentum in y direction, so there is 0, which is equal to here it is minus p sin theta, because this is positive direction, upward is positive and downward is negative, so minus p sin theta plus h nu dash by c sin phi. So this is two equations from momentum conservation. Similarly from energy conservation, we get one more equation, which is h nu equal to h nu dash plus h nu, there is in initial there is a rest mass energy also, h nu plus mc square, which is equal to h nu dash plus e is root of m square c power 4 plus p square c square. Okay, so these are the equations we got. Okay, so here this is the this is here you note one thing, this is we denote like E. Okay, so this E is the total energy of that scattered electron, that will be equal to rest mass energy, this is rest energy plus kinetic energy. Okay, you note this E is kinetic energy plus rest energy, not this E is not equal to kinetic energy of electron. Okay, note that point. Okay, so these are the equations we got from conservation law, and also you note that kinetic energy of that scattered electron will be equal to h nu dash h nu minus h nu dash. Okay, that is energy lost by photon is converted to kinetic energy of scattered electron. Okay, clear? Okay, we already said that kinetic nu dash will be lesser than sorry, okay, nu dash will be lesser than nu, means it come from energy of scattered photon is lesser than incoming photon. Okay, clear? So if nu dash is lesser than nu, then lambda dash, means wavelength of scattered photon, will be greater than lambda, because nu and lambda are reciprocal. You know this already. If nu dash is lesser than nu, then lambda dash will be greater than lambda. Remember this. Wavelength of scattered photon will be higher than wavelength of incoming photon. By using above the equations 1, 2, 3, we can derive an equation for lambda dash minus lambda. I will not go into the derivation part because it make a video lengthy, so I avoid that. Because I am making this video for in competitive examination point of view, I mean especially for ID Jam Physics, so I avoid the derivation. The derivation is very simple, but it may lengthy. So lambda dash become h by mc 1 minus cos phi. This is the equation, 1 minus cos phi. Here phi is scattering angle. That is, let's say this is electron and photon is coming, then this photon will scatter by an angle phi. This is the phi, okay, scattering angle. Here this shift in the wavelength, very important equation, so please try to remember this equation. Okay, here h by mc is also called Compton length, which is sometimes which is denoted by lambda c, which is called Compton wavelength. Okay, so here everything is constant. H is Planck constant, m is rest mass of electron, c is velocity of light. If you put the values, then you get the value 2.46 into 10 to the power minus 12 meter. So lambda c is h by mc is lambda c, which is 2.46 into 10 to the power minus 12 meter. Okay, so we can rewrite this equation like lambda dash minus lambda, which is equal to lambda c into 1 minus cos phi. Here lambda c is h by mc. Here lambda c is h by mc, which is also called Compton length, Compton wavelength. Lambda c is called Compton wavelength. Its value is 2.46 into 10 to the power minus 12 meter. So finally we are going to solve one problem to understand the concept we learned till. So the question is, an X-ray of wavelength 10 picometer. Okay, so the wavelength is given 10 picometer, okay, are scattered from a target. Okay, so the lambda of incoming photon is 10 picometer, which is 10 into 10 to the power minus 12 meter, right? So first question is, find wavelength of X-ray scattered through 45 degree. So there is a photon is coming, lambda, there is an electron which hit on this electron and scattered. this angle is phi, which is given 45 degree. We need to find this wavelength lambda dash. We know the equation of Compton effect, which is lambda dash minus lambda, which is equal to h by mc into 1 minus cos phi, right? Here phi is 45 degrees, so h by mc we know the value. H by mc is 2.46 into 10 to the power minus 12 into 1 minus cos 45. Cos 45 is 1 by root 2. Okay, so use the calculator and we get finally we get 0.718 into 10 to the power minus 12. Okay, lambda dash minus lambda. This is lambda dash minus lambda. So lambda dash is 0.718 into 10 power minus 12 plus lambda. Here lambda is 10 into 10 power minus 12, so it becomes 0.718 into 10 power minus 12 plus 10 into 10 power minus 12. So this is 10.718 into 10 power minus 12, right? So this is, we can write this as 10.7 picometer. 10 power minus 12 is picometer. So we got the answer. Lambda dash, wavelength of scattered photon through an angle 45 degree, is 10.7 picometer. Lambda dash is greater than lambda. So we solved the first question. So next question is find the maximum wavelength present in scattered photon. So here we need maximum wavelength. That means lambda dash become maximum. Okay, the equation is lambda dash minus lambda equal to h by mc into 1 minus cos phi, and lambda dash is lambda plus h by mc into 1 minus cos phi. To get maximum lambda dash, 1 minus cos phi should be equal to what? 2. Means phi equal to 180 degree. When phi equal to 180 degree, cos phi become minus 1. Then 1 minus minus 1 become 2. Okay, 1 minus cos phi should be 2 to get the maximum lambda dash. So lambda dash become lambda dash equal to lambda plus h by mc into 2. Okay, clear? So here lambda we know 10 into 10 power minus 12 plus h by mc we have we know the value 2.46 into 10 power minus 12, this into 2. Okay, then finally we get lambda dash is equal to 14.9 into 10 power minus 12, so it is picometer. So maximum wavelength is given. So maximum lambda dash is 14.9 picometer. So question B also we solved. Then next question is find the maximum kinetic energy of recoil electron. Okay, so option C, kinetic energy of a scattered electron, we know this is h nu minus h nu dash. That means it is hc into 1 by lambda minus 1 by lambda dash. But we need maximum kinetic energy, right? For that, nu dash become minimum. When nu dash become minimum, lambda dash become maximum. Whenever lambda dash is maximum, then only we get nu dash is minimum. Then only kinetic energy become maximum, because h nu minus h nu dash, this is a kinetic energy. To get maximum kinetic energy, this quantity should be less. How can reduce this quantity? By making nu dash is very less. Okay, so whenever nu dash is minimum, then only kinetic energy of scattered electron will be higher. Nu dash become higher only when lambda dash is maximum. So here we need to put the value of lambda dash such as maximum lambda dash, I mean this value. So clear? So kinetic energy maximum will be equal to hc into 1 by lambda minus 1 by lambda dash, which is maximum lambda dash. Okay. So h is 6.626 into 10 to the power minus 34, and c is 3 into 10 power 8, and 1 by lambda is given 10 into 10 power minus 12, minus 1 by lambda dash maxima is 14.9 picometer, which is 10 to power minus 12. Okay. Use calculator and find the value. You will get 6.54 into 10 power minus 15 joule. So this is the answer. So we solved this problem. I hope it is clear. This is about Compton effect. You please try to remember this equation, and then lambda c value is 2.46 into 10 power minus 12 meter. Also remember that also. Then everything is easy. I hope it is clear. If you have any doubt, then please ask in the comment section. Please share this video to your friends, and subscribe my channel and press the bell icon for further notification. Thank you for watching.